Scene script. Have you ever wondered what would happen if humans could breathe in space? Imagine, if you will, stepping out into the vast, endless expanse of the cosmos, drawing in a deep breath and feeling the cool, weightless atmosphere fill your lungs. It's a concept that's captivated the human imagination for centuries, a testament to our insatiable curiosity about the universe. We've always been explorers, pushing the boundaries of what's possible, reaching for the stars, and dreaming of the day when we might finally break free from the confines of our home planet. But as it stands, the conditions of space are far from hospitable. The lack of oxygen, the extreme temperatures, and the vacuum of space present significant challenges to human life. Could we adapt? Could we evolve to survive in such harsh conditions? It's a fascinating question to ponder. Today we delve into the science behind why we can't currently breathe in space and what changes would be necessary for it to be possible. To understand why we can't breathe in space, we first need to understand how breathing works here on Earth. Breathing, a seemingly simple act, is actually a complex process. It begins when we inhale air through our nostrils or mouth. This air travels down the windpipe and into our lungs. Here, in tiny air sacs called alveoli, a remarkable exchange takes place. Oxygen in the air we breathe passes through the walls of these alveoli and into our bloodstream. Meanwhile, waste gas, carbon dioxide, moves from the blood into the alveoli, ready to be exhaled. This delicate process of gas exchange is made possible by the Earth's atmosphere. You see, our atmosphere is a cocktail of gases, with nitrogen and oxygen being the most abundant. Oxygen, which makes up about 21% of the mix, is vital for our survival. It's the fuel our cells need to generate energy. Moreover, Earth's atmosphere exerts pressure, which is key to the breathing process. This pressure helps fill our lungs when we inhale and also aids in the diffusion of gases in the alveoli. Without this atmospheric pressure, our lungs would struggle to expand and contract, and the gas exchange would be compromised. But in space, things work a bit differently. So, what's so different about space that makes it impossible for us to breathe there? Well, it's not just one, but two major factors. Firstly, let's talk about oxygen. On Earth, we're spoiled with a whopping 21% of it in our atmosphere. In space, however, it's a different ballgame. There's virtually no oxygen to breathe. The second factor is atmospheric pressure. It's the force exerted by the weight of air in the atmosphere of Earth. Our lungs are designed to breathe in this pressure, but in space there's no atmosphere, hence no atmospheric pressure. Without it, our lungs can't draw in air, even if there was any to breathe. Let's picture this. Imagine trying to breathe while climbing Mount Everest with no oxygen tank. Now multiply that difficulty by 1,000. That's what breathing in space is like. But what if we could somehow overcome these obstacles? Let's imagine a scenario where humans have evolved to breathe in space. Under this hypothetical, the human body would likely undergo significant adaptations. Our lungs, for instance, might evolve to become more like oxygen tanks, capable of storing large amounts of oxygen for extended periods. Perhaps we could also develop a way to extract oxygen from other sources in space. This could involve a complex filtration system designed to isolate oxygen molecules from other gases, or even from the ice found on other planets and moons. Imagine our bodies functioning like self-sustaining spacesuits, equipped with the necessary tools to survive in the harsh environment of space. This would mean a vast reduction in the equipment and resources needed for space travel. The implications would be monumental. We could spend extended periods exploring the cosmos without the need for bulky life support systems. Such a development would indeed revolutionize space travel and colonization. In conclusion, while the idea of humans breathing in space is fascinating, it remains a far-off dream for now. We've journeyed through the complexities of our respiratory system, delved into the reasons why the vacuum of space is inhospitable to our lungs, and imagined a world where inhaling stardust wasn't just a poetic notion. The cosmos may not be ready for our barefaced exploration, but that doesn't stifle our curiosity or our drive to reach further. Until we find a way to breathe in space, we'll continue to rely on our spacesuits and spacecraft to explore the universe.